Alright, today we move to the last part of the estimation, right? The population proportion. Right, so for this part, the general equation is similar to the previous estimation confidence interval equation formula, right? So the keywords for this part will be proportion, right? The question will give you a proportion. The proportion maybe the proportion can be in ratio, can be in fraction, right? And maybe can be in the percentage, right? So the keyword is the proportion, okay? So when we talk about proportion, we always link the proportion to the binomial distribution, but there are the situations that not always the case are binomial distributions, right? The question that mentioned have proportion doesn't mean this is a binomial distribution, right? But if this question linked to binomial distribution, you can do the similar way, right, to calculate the values. Okay, so for this part, we will use the approximation uh, from a proportion. Proportion normally if we will link to discrete data, okay, and convert to, or not say convert, approximate to normal, okay. So when this you will need to apply the standard limit theorem. So if you want to apply the standard limit theorem, right, then we need to have n larger or equal to 30, right? And for this situation, we will have new distributions with p and pq over n. Okay, so this is things that we need to use to calculate the confidence limit and confidence interval for the proportion of the population. Okay, so if you expand this, you will have a confidence limit p plus minus z pq over n. Okay, and similar things, your confidence interval here will be minus p minus, another side will be p plus, right? And the same things, the confidence the width of the confidence interval will be equal to the width of the confidence interval will be equal to 2 times z pq over n, right? So same things similar to the binomial distribution. P will be the rate that yes, okay. Q will be no, the opposite side. N will be the number of random sample. So this is a general equation that you need to use in order for you to calculate confidence limits or confidence interval. And this is not in your formula booklet, so you need to memorize it, right? Okay, so similar things. So if we have this formula and we can draw the confidence interval, so now the center will be P, right? So another side will be P minus Z square root PQ over N. Another side will be P plus PQ over N, right? And this is the normal distribution, right? So we assume that two sides will be symmetry. And same things, if you still remember that in the chapter of sampling, right? And when we do sampling, if we applies the CLT, we will ignore the continuity correction, right? So we will not apply the continuity correction under this chapter, okay? Because when you have a large sample, the continuity correction that you need to add in is very small, Right, so normally in your syllabus, they will omit the continuing correction, so you can directly take the values and calculate, not need to do any 0.5 again, right? So you can take the values and calculate, right? So this is the things for the last part of the estimation, and now we proceed to question 9. All right, question 9. Okay, question 9. A survey was conducted to find the proportion. Do you see the keywords proportion of people owning DVD players? It was found that 203 of random sample, another keyword random sample of 278 people on a DVD player. Okay, calculate 97% confidence interval for true proportion of people who own a DVD player. Okay, so for first part, uh, you need to, because you have found the keywords there, proportion, and you have found another keyword, random sample. Okay, so and question asks you to find the confidence in the 97% of confidence interval for the proportion of people who own a DVD. So your P will be equal to 203 over 278. Okay, and you may use the exact value in the calculation, right? So your Q will be equal to, okay, so you may use 1 minus the 203 over 278, or as simple is 75 over 278, simple like that. So if you can simplify, if not, then you may use exact value for the calculation purpose. Okay, so now question is asking you to find the 97% of confidence interval. So for 97% confidence interval, the approach is the same for you to find in the previous part, pz z equal to 0.985. Okay, so in this situation, then you will find the z value, okay, from the booklet. So if 0.985, if you refer to the critical value, do you have 985? Don't have. So if don't have, then you need to look at the table. So the measure table will be 2.17. Okay, so 2.17. So once you have this, you can form your confidence limit, and P is equal to 203 278, okay, plus minus 2.17, okay, and I simplify because not enough space, PQ, right? You can put the PQ in from the previous part inside here over the total of N 278. Alright, so you may put in this way. If you can simplify to get the exact value from the previous part, you can directly put inside. If not, you have to use the fraction in order to get the exact value. Okay, so once you simplify and you calculate, okay, so you may have something like that, 0.7302 plus minus 0.0577. This is your confidence limit. So your intervals will be about 0.672 and 0.78. Okay, so this is for question question 9. Okay, question 9 part 1, right? Okay, part 2. A second survey to find the proportion of people owning DVD players was conducted at 10 o'clock on Thursday morning in a shopping center. uh, given one reason why this is not a satisfactory sample, why this is not a good sample. Okay, so don't forget what you need to find is the confidence, the proportion of the people that owning DVDs, the proportion of people that owning DVDs. But now you run the survey at the Thursday morning, 10 o'clock at shopping center. So why this is not a good sample? Okay, so for this question, you need to explain why it's not a good sample. So maybe you can say that, okay, part two. Okay, so when you want to answer this question, you need to answer according to the context. So you may say that this uh, sample do not represent, okay, represent the whole population. Okay, so the sample do not represent the whole population as people selected in the shopping center at this time of day are more likely okay include people who are maybe not working, maybe we say employed, right, owning 10 o'clock. Okay, alright, so this one we consider a normal situation. Alright, so now we all of us in the MCO, then cannot say like that lah, because normal in the working people won't shopping in the shopping center at 10 o'clock, right, on Thursday, right? So, okay, maybe retired or somebody that looking after the maybe his housewife or something lah, right, young children. Okay, so this is the reason, and you may top up some explanation. Then what those who are at work at this time have no opportunity to be selected, right? So that the person that working at this period, okay, 10 o'clock, okay, like us, if we in the normal situation, we will study in we will stay in the college, we will have no chance to be selected, right? So for this kind of question, you can have different answer, but must be reasonable, okay? So you may give different answer and must be reasonable and must be according to the context, right? So this is for question 9. Okay, so let us pause it to question 10. Okay.